Hi, my name is Leon Anavi. I'm a senior software engineer and a huge open source enthusiast. Greetings from Plovdiv, Bulgaria. Unfortunately, I'm not able to make it to this call in person, so this is a pre-recorded video. Recently over Twitter, open hardware makers contacted me and invited me as a guest speaker so that I can share with you my journey with open source hardware. I believe all of you are familiar with the idea about open source hardware, but let's just summarize what are the benefits of using open source hardware. Open source hardware gives confidence that the design will be available if the original manufacturer stops production or stops selling in certain regions. If you are buying some kind of industrial equipment, it's really good in long term to have it open source hardware, because this means that over the years you can maintain it, you can even improve the design. Furthermore, open source hardware keeps the prices low and fair. If you make open source hardware that's super expensive, nobody will buy it, because everyone will see the bill of materials and say, hey, wait a minute, this is too expensive, I can do this in 5 times less. So if you are doing open source hardware, you have to offer it at reasonable prices in order to stay in business. Furthermore, open source hardware allows you repairing and maintaining the hardware. You have all the schematics. That means that you can easily understand if something breaks and repair it. Furthermore, open source hardware enables customizations and integrations in third-party products. This means that you can have one product that's open source hardware, you can grab it, you can integrate it in your product, and have a final product that includes multiple different open source hardware projects within it. Most important is that open source hardware is all about sharing knowledge, educating students, and getting feedback and contributions from the community. The key word here is community. In open source, it's all about the community. You can always do a one-man project, but you need people in order to make good, big projects over time. So there's so many things that claim to be open source hardware, but are they really open source hardware? Are they sharing all the schematics so that you can reproduce it and other people can make it and even sell it? This is a very difficult question, and the answer to this question is provided by the Open Source Hardware Association, which is a legal entity from the United States. They maintaining the so-called open source hardware certification program. This is a directory with various open source hardware projects which have been independently identified as open source hardware solutions. The open source hardware certification program ensures that the definition of open source hardware by a specific project matches the community definition of open source hardware. This means that anyone can use, study, modify, or even sell this open source hardware device. The open source hardware certification program provides a unique ID for certificate hardware based on the country code and a number. For example, as we have it here, I'm from Bulgaria, so the hardware that I'm certifying as part of the open source hardware certification starts with prefix BG, which is the country code of Bulgaria, followed by unique number. Furthermore, the open source hardware certification program provides a unique logo for the certified projects, which it's up to you, the maker, to decide whether to put it on your product or not to put it. To get started with the certification program, you should visit certification.oshwa.org. The whole thing is free, and I believe all of you have something to share. So if you haven't certified it yet, please go to certification.oshwa.org and submit your project. So the really important question is, does it make any sense to use expensive proprietary software for designing open source hardware? Is it worth doing it? Can you build a sustainable community if someone who wants to modify your project needs to pay gazillions just for a license to use the software with which he can edit and modify the open source hardware you did? And the answer is straightforward and simple. No. No, no, no. It doesn't make any sense to use proprietary software tools to design open source hardware. Because of this, I would like to mention that it's super important to use free and open source software in order to design open source hardware. This way you can build up a community. This way more people can freely contribute back and use your project. The ingredients of an open source device are actually several things. It's not just the hardware, it's not just the software. You also need the documentation. So in order to have a successful project, based on my personal experience, you need to combine all these things together so that you can have customers, build community, and grow your project over time. There are so many tools you can use, and this is just a short list. I hope you're already using some of them. If you want to design a printed circuit board, I highly recommend you to use Kicad. This is software that supports designing print circuit boards on multiple layers. It runs on Microsoft Windows, it runs on Mac OS, and it also runs on Linux, and actually I'm using it on Linux. Other options are Fritzing, which is more basic and more simple for designing more like wiring diagrams, Geda, and there are many other tools which deserve a normal mention. However, once again, I repeat, if you are in doubt, use Kicad. I highly recommend you using this. Of course, picking up the tool for designing your printed circuit board is kind of a religion. If you are using Ego or Altium, probably you are not you're not going to easily switch to Kicad, but please give it a try. It's worth it. Here is an example of a very complex project made with Kicad. Olimex is actually a company from my hometown, from Plovdiv, Bulgaria. Also, we are good neighbors and friends, and they have designed this board with A64 called A64 All-in-Oxino. It's with an Allwinner 64-bit ARM CPU, and you can see it's a 6-layer printed circuit board with really complex design, and Kicad is good for this. It can do this board, and most probably Kicad is good for your board and project as well. There are also many free and open source computer-aided design softwares. These are softwares which allow you to design 3D cases for 3D printing or for acrylic cutting, or even a more sophisticated design of cases with, let's say, molding or something like this. And a good case is super important for any product. So here's a short list. Openscad, I really like it because with Openscad you basically write software, write source code, and it generates the 3D model for you. And as I've mentioned in the beginning, my primary job is as a software engineer, so I do a lot of programming. That's why I like Openscad. Other options are QCAD, FreeCAD, LibreCAD, SoulSpacer, and of course Blender. Blender is very sophisticated software, super sophisticated software for 3D modeling and animations. But you can, if you have the craft to use Blender, you can use the skills to apply them for, let's say, industrial design of enclosures and cases. In the previous slide, I've also mentioned that based on my experience with open source hardware, documentation is really important thing. And here comes a short list of options what you can use for making good documentation of an open source hardware project. So of course, no matter what kind of technology you use to write the documentation, you still have to put a lot of efforts and to write the actual content. But we have options with markdowns. Actually, this is the preferred option by me. I just share my projects in GitHub using appropriate licenses, and the documentation is a markdown which with PandaDoc I convert from markdown to PDF. Other options that you can have a look at are LaTeX, HTML, of course, MediaWiki with the wiki markup. Basically, this is what Wikipedia uses. DocWiki is an alternative. Wikifactory, another alternative. Read the Docs is pretty powerful and nice too. I've already mentioned that I'm using PandaDoc to convert files from one markup format to another. In my in my case, from Markdown to PDF. And there's also something going on in Germany. They're trying to create a specification to define the standards for documentation of open source hardware projects. That is pretty cool. I don't know if it's gonna work, because this is something that's happened in Germany. They have their own institute doing it, but why not? Maybe it will become worldwide standard. We'll see over time. One of the important things for each project is how to keep the versions. And over the years, I have seen that most of the hardware engineers are really bad with this. And on the other hand, we have really good craft for this when we're speaking about software. So what I do for my project is that I'm taking the software approach and applying it for version control of the hardware, which means that I'm using Git, and I'm using one of the popular services which provides Git as a service, GitHub. Of course, GitHub is not entirely open source, so I fully understand people who prefer GitLab. Probably this is the better choice. Other options for using Git as a service are Bitbucket or SourceForge. And of course, if you don't like Git, there are alternatives. Mercurial is a decentralized version control system just like Git, but it's not that popular. And also we have centralized version control systems such as Subversion. Once again, based on my experience, I highly recommend you to use Git. So let me talk a little bit more about things that I have created using some of the tools that I've shared with you in the previous slides. My first open source Kicad project from scratch was called Anavi Infrared FAT. This is an add-on board for Raspberry Pi that I've designed 5 years ago, and actually I have updated since then. It's available in GitHub, so just type the name and you find it out. And actually during FOSDEM 2017, I've shared my experience how I've designed this. So if you are interested to learn more what is a Raspberry Pi hat, which stands for hardware attached on top, there is a very strict specification by the Raspberry Pi Foundation how to design add-on boards for Raspberry Pi if you want to call them hats. Just visit this talk. It's a little bit older. There are 5 years since then, but it's pretty cool, and I'm sure it's going to be interesting for you if you are interested in Raspberry Pi open source hardware and add-on boards. So over the years, I have designed many things. Here are some photos of the things that I have designed. All of them are open source hardware. As you can see here, we have a lot of Internet of Things for home automation. We have add-on boards, some mechanical keyboards. Actually, I am even using a mechanical keyboard to record this presentation. Here it is. It's a mechanical keyboard with a display powered by the open source firmware QMK. So yeah, we have so many projects which are now real open source hardware devices, even tools like this fume extractor over here. And I'm using the services of CrowdSupply to crowdfund these projects. Even at the moment, there is a crowdfunding campaign going on at CrowdSupply for an add-on board for Raspberry Pi called Anavi Info Micro Hat. It again follows the specifications and the requirements by the Raspberry Pi Foundation how to design a hat, or a micro hat in this case. It's a super simple project due to the lack of enough chips, due to the global chip shortage. I've decided to do this super small project, which basically has no chips. It's a bunch of connectors which allow you to add a mini I2C OLED display and bunch of sensors to your Raspberry Pi. It has an EEPROM which contains device tree binary overlay information. Basically, this is a software description of the hardware. This way, the Raspberry Pi OS, once it boots, which is actually a Linux distribution, once it boots, it understands what kind of hardware has been attached on top of it. So thank you very much. I hope you've enjoyed this really short talk. Sorry again that I'm not able to be in person with you. Just to summarize again with the conclusions, in my opinion, it is super cool that you are already familiar with what open source hardware is, what are the benefits of open source hardware. please consider using free and open source software for designing your hardware. If you want to learn more about a certification program by the Open Source Hardware Association, please visit their website. I have added some links over here. If you want to get in touch with me, visit Anavi.technology. This is the brand under which I'm publishing open source hardware. If you're interested in selling your open source hardware to other people, visit CrowdSupply if you want to make a crowdfunding campaign. They have a great team. It's super easy to get started with them, especially if you are thinking for a long-term solution based on which you can have a sustainable development of your business model based on open source. OpenX is initiative for bringing open source hardware by small and medium enterprises in the European Union. Visit their website to learn more. And also, if you already have an open source hardware project and you need market for it and you would like to ship it to customers, check out Tindi or Lectrons. Tindi is a company based in the United States. They're part of the Hackaday network. They have a really great community, and Lectrons is something new which is focusing on the European Union. Once again, thank you very much. May the open source be with you, and hope to see you next time on the next meeting. Thanks again.